Hey class, today we're going to learn whether something is going to be classified as acidic, basic, or neutral in terms of the concentration of something. So remember, concentration is how many moles of solute divided by liters of solution. So when we talk about concentration, the unit that we're going to use, remember, is going to be molarity. Now, one thing I do want to point out before we get started is concentration is sometimes denoted with brackets around it. So if I put a bracket and I put H+, this stands for the concentration of my hydrogen ions. So let's get started with a few key things. One of the most important properties of water is its ability to be either an acid or a base. And remember, we said that this was called amphiprotic. So as an acid, it can act as a proton donor, or in other words, it gives away an H plus ion. As a base, it acts as a proton acceptor, or it's going to take in a hydrogen or an H plus ion from another compound. So the fact that one water molecule can actually donate a proton to another water molecule is called the autoionization of water. So if you have a bottle of water, it's not going to be pure H2O. Those H2O molecules are actually reacting with each other. And so you have a very slight concentration of hydroxide ions in your water when you're drinking it, but also H3O plus hydronium ions as well. Now remember, hydronium and H plus ions are often used interchangeably. They mean the same thing in terms of what we're talking about now. So when we have this, we're going to talk about an equilibrium constant for the autoionization of water. So here our equilibrium constant is going to be the concentration, so that's what these brackets mean, of your hydronium, or also known as your H+, because remember, these can be used interchangeably, times the concentration of your hydroxide ion, and this is always going to equal 1.0 times 10 to the negative 14th. So let's talk about the acidity, basic, and neutral. Well, let's talk about neutral first. If our hydrogen ions and our hydroxide ions equal each other, this is going to be neutral. Now remember, that number was 1.0 times 10 to the negative 14th. Well, if I have to divide that by 2, anything that's neutral is going to be getting the concentration of 1.0 times 10 to the negative 7th is going to be its molarity if it's a neutral solution. Okay. However, the H plus and OH concentrations are not always equal. And one thing to note is as the concentration of one of them increases, the other one has to decrease. And the reason for this is their product always has to equal that 1.0 times 10 to the negative 14th. So remember, your equation is H plus times OH equals, so if this times 10 to the negative 14th cannot change, if this one goes up, this one has to go down. Now, how do we say if something's acidic or basic? Down here, an acidic solution is when the H plus concentration, so notice that it's always referring to the H plus, is greater than 1.0 times 10 to the negative 7th. Now, we are working with negative exponents. So remember, things that are bigger are things like negative 6, negative 5, negative 4, negative 3, negative 2, and even negative 1. A basic solution is where the H plus, so again, look, we're focusing on this H plus concentration, is less than 1.0 times 10 to the negative 7th. So remember, we're working with negative. So if we're going to become less than, we're becoming more negative. So things like negative 8, negative 9, negative 10, negative 11, negative 12, negative 13, and even negative 14. So here, if we look at these, we need to be able to see that these are all H plus concentrations. We need to look at their molarities and say, are they neutral, acidic, or basic? So here we get the first one, and we're mainly focused on the exponent. So here is my exponent, and it's a -9. You're going to notice that this is less than -7. So this would be classified as basic. Here, this concentration is exactly 1.0 times 10 to the -7th. So this one is neutral because it's equal. And then here, this -3 is bigger than -7. So this one's considered acidic. Now going on, we can calculate our H plus concentration if we're given our OH and vice versa. So remember our equation. Hydronium, which is still the same thing as H plus, they're used interchangeably, and hydroxide are going to equal 1.0 times 10 to the -14th. And if you know either one, you can solve for the other. So here I have a couple examples. Calculate the concentration of a hydrogen ion in a solution in which the hydroxide is going to be 0.010 molarity. So in our equation, I don't know my hydrogen concentration, and that's going to be multiplied to my hydroxide. And I know my hydroxide, 0.010 molarity. And remember, this all has to be equal to 1.0 times 10 to the -14th. And then it's just a simple trying to get H by itself. Well, you can do that by dividing by 0.010 because I'm multiplying here, so to undo it, it's division. And so you can divide this to get H by itself. And when you do that, make sure you put it in your calculator using your parentheses, and you're going to divide, and you're going to get 1 times 10 to the -12. And your calculator might write it as 1e -12. And all that's saying is 1 times 10 to the -12. Now, we do have to pay attention to sig figs, and this only has 2 sig figs. So this is actually written as 1.0 times 10 to the -12th. And our unit is going to be molarity. On your homework, I'm going to have you classify this as acidic, basic, or neutral. So here we found our H plus concentration, so we need to look at this number right here. And since this -12 is less than -7, this is considered a basic solution. Down here, if we were to solve, same thing. I don't know my H plus concentration. I do know my OH, so that's going to be 1.8 times 10 to the -9th. Oops, brackets. And this is all going to equal that 1.0 times 10 to the -14th. So again, just like anything else, you want to get H by itself. So you want to divide by your 1.8 times 10 to the -9th. And when you do that, you're going to get the following answer. But before I give you the answer, again, make sure when you plug it into your calculator, you're using parentheses. So 1.8 times 10 to the -9. And you're going to get, oops, I plugged that in wrong. 1 second. I was wondering why my answer was off. Here we go. You're going to get 5.5 repeating, so you can put 5.6 because we need 2 sig figs times 10 to the -6. And this is going to be in molarity. So since I found my H plus concentration, I can look at my exponent here, and this is going to be considered acidic because this number is greater than -7. Now, we do want to do a little bit of practice. Well, what if you are given the H plus concentration and not the hydroxide concentration? Well, you can use the same exact equation. So in class, I actually just went over the first two. If you want to go over the last one, you guys can come up and ask for help if you still need it. But we're going to focus on the first two. So here on our first one, same thing. I now know my H plus, so I can plug that in. I don't know my hydroxide, so I'm going to just keep it as hydroxide. And this is still going to equal 1.0 times 10 to the negative 14th. Just like the previous problems, we're going to try to get OH by itself now. And so we're going to divide by that 2.0 times 10 to the negative 6th. So I'm going to go ahead and plug this into my calculator and see what we get. And when you get this, you should hopefully get 5, and I need 2 sig figs here. So 5.0 times 10 to the negative 9th molarity. Then on your homework, I'm going to ask you, is this an acidic, basic, or neutral solution? And this is where most people make their mistakes. They're going to try to tell me that this is going to be basic based on this negative 9. But remember, this is our OH concentration. You have to always base your answer off the H plus concentration. So you need to be looking at the 2.0 times 10 to the negative 6th when you're telling me if this is acidic, basic, or neutral. So you'll see that this negative 6 is greater than negative 7, so this is actually an acidic solution. And the last one, if I have an H plus and it equals an OH negative concentration, here you would plug in X for my hydrogen, X for my OH, and this is always going to equal 2.0 times 10 to the negative 14th. And this combines to become 2x equals 1.0 times 10 to the negative 14th. And then if you divide by 2, this is eventually going to be 1.0 times 10 to the negative 7th molarity. And we've talked about this. Whenever it is neutral, this is going to be its concentration. When they equal each other, it is neutral. So that's the end of today's lesson. If you had any questions, please make sure that you reach out and ask. But otherwise I hope you guys have a great day.